Imagine traveling from Beijing to Shanghai, a distance of over 1,000 kilometers, in just under an hour. No turbulence, no traffic, just pure speed, silently gliding through a vacuum tube at 1,000 kilometers per hour. Hey, I'm Aiden. Welcome back to the channel. Today, we're diving into one of the most mind-bending engineering projects on Earth. China's plan to build a Hyperloop-style train that travels at 1,000 kilometers per hour through a vacuum pipeline. Welcome to China's latest engineering frontier, the T-Flight Hyperloop, a next-generation transportation system designed to redefine what fast really means. While the rest of the world debates and experiments with the concept, China is quietly and rapidly building what could become the fastest ground transport system ever created. This isn't science fiction anymore. This is the race for the future of travel, and China might just be in the lead. The idea behind a Hyperloop is simple but revolutionary. Place a train-like capsule inside a sealed vacuum tube, drastically reducing air resistance and friction. Then, use magnetic levitation, or Maglev, technology to lift and propel the capsule forward, achieving near-supersonic speeds. Theoretically, in a near-vacuum environment, such a system could reach 1,000 kilometers per hour or more, making it possible to travel faster than a commercial airliner, but on land. While Elon Musk popularized the idea back in 2013, it's China that's turning the Hyperloop dream into a national megaproject. At the heart of this initiative is China Aerospace Science and Industry Corporation, or CASIC, a state-owned high-tech giant, usually known for building missiles and space vehicles. In 2017, CASIC unveiled its ambitious T-Flight program, a Hyperloop-style transportation system using vacuum pipelines and magnetic levitation to achieve unprecedented speeds. By 2021, they completed the world's first full-scale vacuum Maglev test track in Datong, Shanghai province. This initial tube was about 2 kilometers long and designed for small-scale testing of propulsion, levitation, and vacuum systems. In the years that followed, China continued expanding the prototype, aiming to build a 60-kilometer-long test line capable of supporting real passenger pods. Their ultimate target? A fully functional system that can reach 1,000 kilometers per hour, connecting major cities like Beijing and Wuhan, or Shanghai and Chengdu, in under an hour. So, how exactly does China's Hyperloop, or T-Flight, work? The train, or capsule, uses superconducting magnetic levitation, the same core technology that powers China's Shanghai Maglev, currently the fastest commercial train in operation at 431 kilometers per hour. But unlike the Shanghai Maglev, which runs through open air, the T-Flight capsule travels inside a sealed vacuum tube, where air pressure is reduced to almost zero. This means there's virtually no aerodynamic drag, allowing the capsule to accelerate faster while using far less energy. Linear electric motors push the train forward, while sensors, AI control systems, and advanced materials keep it stable, safe, and perfectly aligned, even at near supersonic speeds. And because it levitates, it produces no contact friction, making the ride ultra-smooth and nearly silent. Reaching 1,000 kilometers per hour isn't just about speed, it's about precision engineering. At those velocities, even minor imperfections in the tube's structure could cause turbulence or catastrophic pressure imbalances. To counter this, CASIC engineers are developing high-strength composite materials, real-time monitoring systems, and vacuum seal technology capable of withstanding extreme stress. Safety chambers, magnetic stabilizers, and AI-controlled emergency brakes are being designed to handle any power loss or vacuum failure. In short, every element must perform perfectly, or the system fails, and China is investing heavily in the research infrastructure to make that possible. Around the world, Hyperloop projects have faced slow progress. In the US, Virgin Hyperloop One scaled back operations in 2022, shifting focus from passengers to cargo. European initiatives in the Netherlands, Spain, and Switzerland remain largely in prototype stages. But China, with its centralized planning, rapid infrastructure rollout, and experience in maglev rail technology, may have the unique capability to actually deliver a working system first. The same nation that built 40,000 kilometers of high-speed rail in just over a decade is now betting big on vacuum transport as the next leap forward. If successful, the impact would be transformative. A journey from Beijing to Guangzhou, currently 2,200 kilometers, could take just 2 hours instead of 10. It would revolutionize commuting, connect regional economies, and potentially replace short-haul air travel, drastically cutting carbon emissions. For China, it's also a symbol of technological dominance, showcasing the nation's ability to lead in cutting-edge infrastructure beyond just traditional high-speed rail. Of course, the road, or rather the tube, ahead isn't easy. Building a nationwide vacuum transport network will cost hundreds of billions of dollars and require flawless safety records to gain public trust. Then there's the question of energy consumption, maintenance, and real-world scalability. Even if the technology works perfectly, will it be affordable? Will it ever make commercial sense outside of limited, ultra-high-demand routes? These are the questions that even China's engineers are still wrestling with. Still, progress continues, quietly, methodically, and with the kind of determination that has defined China's rise in science and technology. From high-speed rail to lunar missions, and now, the vacuum Maglev Hyperloop, China is chasing the edge of what's possible. Maybe one day soon, we'll step into a sleek capsule, feel the soft whoosh of acceleration, and before our coffee even cools, we'll arrive in another city 1,000 kilometers away. This isn't just transportation. It's the future of human movement. Welcome to the age of 1,000 kilometers per hour. I'm Aiden, and thanks for watching What Now Viral. Leave a comment and subscribe to keep up to date with what's viral. See you on the next one.